What's poppin', dogs? Mr. Allen here with an introduction to special right triangles. We've got our 45, 45, 90 triangle and 30, 60, 90 triangle. Now, we introduced these in geometry, but they are used continually throughout mathematics in Algebra 2, Pre-Calc, and beyond. So let's start with the 45, 45, 90 triangle, also known as an isosceles right triangle. Why is that? Well, isosceles means that two sides are congruent. If I have two congruent angles, those two legs are also going to be congruent. Cool? Now let's start with our most basic length we could think of. How about 1? This side here is 1. The other side's got to be the same length. And through Pythagorean theorem, 1 squared plus 1 squared equals c squared, I could get this guy right over here to be the square root of 2. Now what's really neat about special right triangles is that we can scale them up and down by any multiple we want as long as we have those angles. So in other words, I could call this guy 1x and this one 1x, and this over here as x root 2. So any number I have here, I could find my other sides. Check it out. If this right here is, say, 5, then this guy over here is going to be 5. And if x right now equals 5, right, because 1x equals 5, pop a 5 right over here, and I've got 5 root 2. Don't believe me? Think that is just mathematical magic? Let's check it out through Pythag, okay? So 5 squared plus 5 squared equals c squared. 25 plus 25, that's 50, equals c squared. Then I would have to square root on both sides. Break down that 50 with a factor tree. 2, 25, 5, and 5. Got my pairs. We get 5 root 2. Oh my goodness. So there we go. Nice little mathematical shortcut using these special right triangles. Super duper cool. So in other words, let's maybe make like a little rule here. If I want to go from my short side to my longer side, I would just multiply by the square root of 2. How would I go back? How could I go back the other direction here? Can we do that? Could I go this way? Well, if I got to multiply by root 2 to go this way, I'd have to divide by root 2 to go the other way. So I'll divide by root 2 to go from long side to short side. Okay? We'll have to do some examples with that one, but that's our rule right there, is that if I have the short side, I can multiply by root 2 to get the long side. If I have the long side, I got to divide by root 2 to get the short side. As you can see it here, if this is 5 root 2 and I divide by root 2, root 2's cancel, I get back to 5. Sometimes it's a little more complicated. We got to do some denominator rationalization and fun things. We'll save those for some later examples. All right? But there is our 45, 45, 90 triangle, our basic rule. Now we're ready to rock and roll with the 30, 60, 90 triangle. So first off, we'll start with the short leg being 1, just like the 45, 45, 90. But which one is my short leg? Well, it's the one across from the smallest angle, so this would be 1. Now I'm going to give you guys the other ones here, and you could check it through Pythagorean theorem and find them in other ways. So I'm just going to give them to you for this video. This side is going to be root 3, and this side is going to be 2. And just like the 45, 45, 90 triangle, this guy would be 1x, this is x root 3, and this is 2x. So if I have the short leg, it's super easy to get the other ones. Let's say, once again, that this is 5. That would make this one, well, x is 5, so this would be 5 root 3. And this over here would be 2 times 5, which is 10. Voila. Beautiful. So let's write down some rules here. To go from the short side to this guy, I would multiply by the square root of 3. To go to my long side, we multiply by 2. Easy as that. Easy as that. But what about if I have the long side, or if I have the medium-sized side, the root 3 side? What do I do then? Well, if I wanted to go from here to here, I would multiply by root 3. To go back the other way, I would divide by the square root of 3. And if to go from the short side to the longest, I multiply by 2. To go back, I would divide by 2. Lovely. Everything runs through the short side on this one, okay? Everything runs through the short side. If I have the long side, divide by 2 to get to the short, then I can get the medium one by multiplying by root 3. If I have this side, I'll divide by root 3, then I'll multiply by 2 to get to the long side. So everything runs through the short side in the 30, 60, 90 triangle. A little more difficult because you have 3 different sides as opposed to this guy here, but same kind of ideas. Remember the patterns, remember the rules here, and then it's no big deal, okay? Well, a little bit of it. there's always challenges in math. Let's do a quick example here. We'll grab maybe 2 examples. We'll see what we have room for. I'm actually going to do, we'll do 1 example for this. And we'll save for some other ones here in a little bit. Let's say that this is a 30, 60, 90 triangle. Sometimes we give you both angles. Sometimes we only give you one. Okay, and then you have to figure out the other one based on having 30 degrees and a right angle. That guy has to be 60. Or if I have a 90 and a 60, I know that has to be 30. Let's say I've got 16 for this, and I got to solve for x, and I got to solve for y. Well, I have my long side, right? I have the longest side. So if this is 16, I would divide by 2 to get back to my short side. Just like that rule says right there, divide by 2 to get back to my short side. So this makes x going to be equal to 8. So if I take 16 divided by 2, I get 8. Now I have my short side. Remember, everything runs through the short side with these. How do I get to my medium-sized side? I got to multiply by the square root of 3. So this makes y 8 square root 3. If you don't believe me that this magic works, you can check it with Pythag, but I assure you that it does. So wonderful, fantastic, 30, 60, 90, and 45, 45, 90 triangles. Special right triangles. They are special. They aren't going anywhere in math. They'll be coming up all the time. So know your 2 rules there, your 1 and your root 2, and then your 1, root 3, and 2 for your 30, 60, 90 triangle. There's different ways of setting these up. Some like to use proportions. I like to remember this of like multiply, divide, and then do the rationalization if necessary when it comes up. But I'll show that in some future examples. Thanks for watching the intro video, guys. Stick around and have a great day.